In this example, we're going to find the sum or the difference of matrices either being added or subtracted. In order for us to have some matrices to take a look at, up at the top here, I have named 4 different matrices with capital letters. Matrix A is this 2 by 2 matrix, and B and C and D are there. In order for us to add or subtract matrices, we need to know, first of all, if it's possible, unlike regular numbers, where you can always add or subtract and get an answer. With matrices, you can't always do that. You can't always add 2 matrices together or subtract 2 matrices. In order for you to add or subtract matrices, they have to be the same dimension or the same size. So matrix A here has 2 rows and it is 2 columns. The only thing I could add or subtract to this matrix are other matrices that have 2 rows and 2 columns. Matrix C, that has 2 rows and 3 columns. The only thing I could add or subtract to that matrix would be other matrices that are exactly 2 rows by 3 columns. So let's run through a couple of these. To start with, let's take a look at taking matrix A and matrix B and adding those together. Matrix A is the 2 by 2 matrix 2, negative 4, 3, 4. Matrix B, that is our 2 by 2 matrix 0, 5, negative 6, 4. Both of those matrices have the same dimension, so we will be able to add those together. When you add or subtract matrices, the answer is going to also be the same dimension as the original. So we have 2 2 by 2 matrices that we're going to be adding together. Our final answer is also going to be a 2 by 2 matrix. How you add and subtract matrices is you add each element that is in the same position in the matrix together, and you put your answer in that same spot in the final answer of your matrix. So for instance, in the upper left hand corner we have row 1 column 1 in matrix A, that's the number 2. In row 1 column 1 in matrix B, that's the number 0. We're going to add those together, so 2 plus 0 is 2, and we put that answer also in row 1 column 1. And you just do that positionally through all of the different values, all the different elements inside your matrices. So in the upper right hand corner we have negative 4 plus 5, that's 1. Lower left hand corners we have 3 plus a negative 6, that's a negative 3. And in the lower right hand corners 4 plus 4 gives us 8. So the sum of matrix A and matrix B is this 2 by 2 matrix. Let's take a look at taking matrix A and matrix C and adding those together. Matrix A plus matrix C. Before we do any adding or subtracting, we should see if it is possible. Here we have a 2 by 2 matrix. We're adding a 2 by 3 matrix. Those matrices are not the same dimension, so we cannot add or subtract them. Oops. That is impossible. Matrix D minus matrix C. Let's take a look at that. Matrix D, that is the matrix 707, 26, negative 8. And from that we want to subtract matrix C. That is a 2 by 3 matrix minus another 2 by 3 matrix. They are the same dimension, so we will be able to add or subtract them, and the answer is also going to be a 2 by 3 matrix. So running through each element position by position, upper left-hand corner, 7 minus 5 is 2. In row 1, column 2, we would have 0 minus a negative 2, which is 2. And in the upper right-hand corner, 7 minus 6 is 1. Row 2, column 1 would be 2 minus 1, which is 1. Row 2, column 2 is 6 minus 0, which is 6. And then in row 2, column 3, we would have negative 8 minus 4, which is a negative 12. And that would be our answer to matrix D minus matrix C. In addition to adding and subtracting matrices, we can do two different types of multiplication. Here I'm going to be talking about something called scalar multiplication. And what scalar multiplication is a number times a matrix. So for instance, I could do 10 times matrix A. In order to do scalar multiplication, a number times a matrix, you don't need any qualifications. It doesn't matter the size of the matrix. You're always going to be able to do a number times a matrix. So for this problem, I want to do 10 times matrix A. Matrix A is our 2 by 2 matrix, 2, negative 4, 3, 4. When you do scalar multiplication, your final answer is going to be the same size as the original matrix. And what you need to do is take the number that's in front and multiply each one of the elements on the inside by that number. So I want to do 10 times each one of these values. So 10 times 2 is 20, 10 times negative 4 is negative 40, 10 times 3 is 30, and 10 times 4 is 40. That is our answer to that scalar multiplication problem. You can combine those different operations together into one expression or one problem. So for instance, we could do 2 times matrix B plus matrix A and do that calculation. PEMDAS does hold when you are working with matrices. So we have the operations of multiplication and addition here. We would want to do multiplication first. So we're going to multiply 2 times B first, and then in the next step we would add matrix A to that. So 2 times matrix B would be 2 times the 2 by 2 matrix, 0, 5, negative 6, 4. And then to that we would like to add matrix A, which is 2, negative 4, 3, 4. Two operations again, multiplication and addition. We would do the multiplication first. So first I'm going to multiply 2 times each one of the elements in this matrix. So that would be 0, 10, negative 12, and 8. Didn't do anything with this second matrix, so I'm just going to copy that down again. So I did 2 times the matrix, and now we're going to do an addition step with these two matrices. It is a 2 by 2 plus another 2 by 2. They're both the exact same size. So I will be able to do the addition there. I just need to go through position by position and add the two matrices together. So in the upper left-hand corner, 0 plus 2 is 2. Upper right-hand corner, 10 plus negative 4 is 6. Lower left-hand corner, negative 12 plus 3 is negative 9. Lower right-hand corner, 8 plus 4 is 12. 2 times matrix B plus matrix A would give us this 2 by 2 matrix for our final answer.